Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to explain more about how you can use the moment generating function in order to generate moments about the origin. And I've said this in the previous video where if you have um, MGF, okay, the idea of this name itself, the MGF, is closely related to the fact that you can use this function here to generate moment about the origin. So what is moment about the origin? Recall that this is something that you have seen before in the previous video. The type of moments that you have seen are moment about the origin and moment about the mean. So when you talk about moment about the origin, this is something to do with finding, for example, ex or ex squared or ex cubed or exn. Okay, so whatever n is. So that is a moment about the mean, and in this video I would like to explain about the idea of using MGF, moment generating function, to generate moment about the origin as such. Okay, right, so according to the theorem here, we have our x as a random variable, and the MGF of x is given by this function here. So this is psi, and it depends on t, and it is said to be finite for all values of t in some open interval. So we have some interval around the point t is equal to 0. Then for each integer n greater than 0, the nth moment of x, so you're talking about the nth moment of x, which is this one. Mathematically, the expression is this. The nth moment of x is also finite and given by this formula. So in order to find exn, okay, you have to consider the MGF. So here is the MGF, and you have to differentiate it n times and substitute the value of t equals to 0. So that is the process. Okay, so for example, I'm giving you a simple example. Let's say you would like to find the second moment, okay, second moment about the origin. So in order to do this, the first step is you need to find what is the MGF of x. What is the MGF? And since you are interested in finding the second moment, therefore you need to differentiate the function here twice. Second moment, differentiate twice. And so the third step is, once you get the result, you substitute the value of t according to 0. So you use 0 here, substitute 0 into t, and this is the result of ex squared. Okay, and using the same idea, of course, you can find whatever nth moment that you like to find. For example, you want to find exn. So again, the first step is just to find what is the MGF of it. Second step is to differentiate n times because you want to find the nth moment. And the third step is you substitute the value of t to 0. Okay, so once you get the second step, then you substitute 0 into t, and you'll be able to get the nth moment. So that's the idea, very simple idea. Now without further ado, we're going to look at straight to this example here. And here we have a binomial distribution. So x is a binomial distribution, and this is the distribution of x. Okay, so this is the distribution of x. Notice that x is the values take from 0, 1, 2 until n, and here is the probability distribution. Okay, this is something that you have seen before. Now the first question is asking you to find the moment generating function of x, and then you're going to use the result in A to find the mean and variance of x, okay, or to demonstrate that the mean and variance of x is indeed these values here. Okay, let's start off with finding the MGF of x. The idea to find the MGF of x is, of course, first you have to recognize, is this discrete or continuous? And this is a discrete random variable, so we know that we are dealing with the summation process. Okay, summation process. And you are going to find what is the expected value of e to the tx. And this is just summing up this function here with so here we have e to the tx times with fx, so summing up with respect to x, and we are just going to substitute our probability distribution here, which is just nx px 1 minus p n minus x. And what we can do is x here is you can also, if you want to be more precise, we can consider x from 0 until n. So okay, how do you know x from 0 until n? So it's stated here. The values of x can take minimum values of 0 and it goes up until n. Next, what we can do is, well, you see that here we have x and over there we have x. Now we can use the law of exponent to combine these two terms together, and this is how it's going to look like. So we have x equals 0 n, over here is nx, right here is just p e t x. Okay, we're combining these two terms together, and 1 minus p and minus x. I'm just going to use this space. Next, the result is just going to be well, it's going to be this whole process here can be represented as 1 minus p plus PET, and over here we are going to have n, sorry, okay. So over here, so here is 1 minus p from this part, PET over here, this is n. So the result here comes straight from the idea of binomial expansion. Okay, so the whole process here can be simplified as such, and so this is the moment generating function of x. Okay, so the result here comes from binomial expansion, the idea of binomial expansion. Okay, so I'm just going to briefly explain what is the idea of binomial expansion. So let's say you have something like this. Okay, so here you have n, x is equal to 0, nx. Over here is px, q, n minus x. Now, according to the formula or the theorem given by binomial expansion, the whole thing here is equal to q plus p to the power of n. So you take this q, p, and over here is n. So similarly, what we have over here is 1 minus p, so it goes right there, and PET goes right here to the power of n. So that is the result, and this is the MGF of x. Now I think I might have to do, well, a video to explain more about the binomial expansion, and I think I'll talk about it in the next video. Okay, so from this moment, let's just take this information. So this is the formula for binomial expansion, something useful to remember. But the idea of it, well, I think I should create one video to just talk about this idea, and I will talk about it in the next video. Okay, Now let's move on to what we are supposed to do, which is we would like to find this part here. Use the result in A to demonstrate the mean and variance is as such. Well, you have seen the value of this before in the chapter 4, so you know that the mean is NP and the variance is NP1 minus P. So we are going to use the result that we get here, so this is the MGF, and find the mean and variance to be as such. Okay, let's start with finding the mean. So we're going to use our MGF. Our MGF is 1 minus P plus PET to the power of n. So that is our MGF. And therefore, if you want to find e to the power of x, okay, what you have to do is, well, here is 1 actually, therefore you know that the MGF here has to be differentiated once. So what is the result of differentiating this function one time? What happened here is we're going to use the chain rule idea. Therefore the result here is going to be n will be brought forward, so here we have n, and we're going to maintain the whole thing inside here. It will be 1 minus P plus PET to the power of n minus 1. Okay, you differentiate it, and then you are going to focus on the inside of this bracket and differentiate it with respect to t. Okay, so what happened when you differentiate this with respect to t? The answer is going to be 0. What happened when you differentiate it with respect to t? It will be PET, so it maintains at PET. Okay, right. Then what you have to do is you have to substitute t with 0. So substitute t with 0, it will be n. So here we have 1 minus P plus P e to the power of 0 will be equal to 1. So I'm not going to write 1 here, so just n minus 1, yes. Over here, 0 plus P times e with 0. E to the power of 0 is also equal to 1. So that's what we have over here. Simplify the result. 1 minus P plus P, it will be 1. N minus 1. Over here is P. 1 to the power of whatever, it's going to be 1. So the result is just NP. Therefore, the first moment about the origin is the mean, which is equal to NP. So that's it. That's the step of using MGF to generate whatever moments of the origin that we need to find. Right, let's look at the next part, which is to find the variance. And well, you know that in order to find the variance, so variance of x, the formula that you need to find is, the formula that you need to work with is actually ex squared minus ex, and you square it. So this part over here we have already obtained right there, and now our job is to find what is this value right here. Okay, so we are going to repeat the steps again, and this time we are going to look for the value of ex to the power of 2. So what is ex squared? In order to find ex squared, we can again, so we use, or we consider the MGF, which is given by this expression here, 1 minus P plus PE to the T, and here is N. Okay, therefore we have to differentiate it twice, and we have already differentiated it once, and the result is given here. So this is the result when you differentiate once. Okay, I'm just going to take the result. It is well, n 1 minus P plus P e to the T, n minus 1, so that's the result, times with PET. Okay, 0 is out, times with PET, and I'm just going to rearrange it nicely. Okay, so it's looking like this. Okay, so if you want to find the second derivative, we're just going to differentiate this. We're just going to differentiate this one more time, and you will get the second derivative. So therefore, the second derivative is going to be, well, you can consider this part, this part to be f, and this part to be g. So we can use the formula of fg prime plus gf prime in order to get the second derivative over here. Okay, right, that's what I'm going to do. So f is just npet, I'm just writing it down, f, and then g prime, so I'm going to differentiate this whole thing. So to differentiate this, I'm going to use the chain rule. Therefore, the power here will be brought forward, n minus 1. Maintain whatever it is in the bracket. So we have 1 minus p plus PET. And the power at the top here is going to be n minus 1 minus 1, which is n minus 2. Then you have to differentiate whatever it is in the bracket here. So when you differentiate 1 minus p, it's with respect to t, it's going to be 0. And differentiate pe to the t, it's going to be PET. So that is the result of g prime over here, right here. Okay, so here is f, and here is g prime. Okay, g prime. Next, we're going to plus with gf prime. So g is the whole thing here, g, 1 minus p plus PET, n minus 1, so that is our g. Differentiate f with respect to t. Np are constant, so we are going to maintain that value. Differentiate et is going to be et as well, so that is the result of gf prime. So here is g, and over here is f prime, according to the formula given. Right, next, we're just going to substitute t 0 into t, so that's what we're going to do next. Okay, substitute 0 into t, and that becomes np e to the power of t is 1. Okay, I'm just going to write it like that. N minus 1, 1 minus p plus PET, so 1 minus p plus p times 1, e to the power of 0 is 1. 1 minus p plus p, so it will be 1, n minus 2. And over here, p times e to the power of 0, p times 1, so just p right there, plus, well, 1 minus p plus p, e to the power of 0 is 1. E to the power of 0 is 1, so 1 minus p plus p is just 1, n minus 1. And p e to the power of 0. E to the power of 0 is 1, again, t is 0. So here we have np. Okay, now we have np, n minus 1, 1 to the power of whatever is 1. This is p. Okay, plus 1 to the whatever power is just 1 times np, so this is np. Simplify that, so that becomes n p times n, so n squared p times with p, so it will be p squared over here. So np times n times p. Okay, so n squared p squared minus np squared, yeah, np times negative 1 times p, so npp, so np squared plus np. And this is, well, the result of ex squared. Okay, let me just use the space right here. Therefore, variance of x again it's just ex squared minus ex, and you square it. What is ex squared? This guy. So that is n squared p squared minus np squared plus np. And what is this? Ex. Ex is just np, so you square it, minus n squared p squared. Okay, when you squared np, so np, you square it, you get n squared p squared, and this is used right there, n squared p squared. Clearly you can cancel that out, and so what is left is np minus np squared. Factor out np, so 1 minus p, and this is variance of x. So this is what you are asked to demonstrate in the question given here. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video.